Chapter 7.3 covers similar triangles. In this chapter, we're going to look at shortcuts to prove that triangles are similar. The first one we have is AA similarity. If we can show that two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. In the first problem, we're asked to determine whether triangles are similar. If so, write a similarity statement. In triangle ABC, we know that these two of the angles are 42 degrees and 58 degrees. If we add those up and subtract from 180, we would get that angle A is 80 degrees. So looking at the two triangles, B and D are both 42, A and E are both 80. So yes, they're similar by AA, similarity. So triangle ABC is similar to triangle EDF. In the next problem, we're told that QP is parallel to MP. So we know that angle P and angle M are congruent. And we also know that angle Q and angle N are congruent. And we know that because we have parallel lines, and that gives us that alternate interior angles are congruent. So we have, yes, they are similar by AA similarity. And triangle PQX is similar to triangle MNX. Doing problem A, we have that B and C are 42 degrees and 52 degrees. Adding those together and subtracting from 180 would give us that A is 86 degrees. So we have angle B and angle F, and angle A and angle G are congruent. So yes, by AA, we have that the triangles are congruent. And would it be ABC, ABC, and F? Well, A and F are not the same. A and G are the same. B and F are the same. So it would be this. In problem B, we're asked again to determine if the triangles are similar. We have parallel lines. So we know that Z and X are congruent. We know that Y and W are congruent, both because they're alternate interior angles. So we know that Z and X line up, going through these, Z and X, W and Y. So it'd be the yes one, and it'd be by AA similarity. We have two other ways to prove that they're similar. First one is by side-side-side similarity. If we can show that the corresponding sides lengths are proportional, then the triangles are similar. The other one is side-angle-side similarity. Again, the angle has to be between the two sides that are proportional. So for the first problem, we're asked to determine whether the triangles are similar. If so, write a similarity statement. So 9/6, which is AB over DE, that can reduce to 3/2. If I try AC over CE, that's 6/5, which doesn't work. So let's try AC over CD. That's 6 over 4, which also reduces to 3 over 2. So we're left with BC over CE, which is 7.5 over 5, which also reduces to 3 over 2. So yes, they're similar by side-side-side similarity. And triangle ABC is similar to triangle DCE. Looking at the next problem, we're going to be looking at the small triangle and the large triangle. So we're going to be looking at the triangle here on the top and then the whole triangle here. So this whole entire side length is 12 plus 18, which is 30. And this side length here is 10 plus 15, which is 25. We know that angle M is congruent to angle M. Both triangles have angle M in them. So we want to see is MP over MS, is that the same as MN over MR? So MP is 12 over 30, which reduces to 2/5. MN is 10 over 25, which also reduces to 2/5. So yes, by side angle side similarity, and triangle MNP is similar to triangle MRS. Next problem asks us to determine whether triangles are similar. If so, choose the correct similarity statement and reason. So looking at this, we can show that the vertical angles here are congruent. And let's see if the corresponding sides are congruent. So let's try PR over RS, which is 4 over 12, which reduces to 1/3, and QR over RT, which is 2 over 6, which also reduces to 1/3. So we know that they're similar by side angle side similarity. And if we line it up, PQR, STR, so B. Problem B. Determine whether the triangles are similar. We know that they both share angle A. The length of the long side here is 15. The length of this one is 13.5. So AE over AC is equal to 9 over 13.5, which is 0.9. AF over AB, 10 over 15, which is also 0.9. So it's yes by side angle side. We have two of them that are side angle side. A corresponds with A. I know that E corresponds with C. So it would be the first one. If triangle RST and triangle XYZ are two triangles such that RS over XY equals 2/3, which of the following would be sufficient to prove that the triangles are similar? So we either have to do angle, angle, side, 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 or side, angle, side. Well, if we had C, it'd just be one angle, so that wouldn't work. RT over XZ, ST over YZ. Well, we'd have to show that they were also equal to RS over XY. So we'd have to show by side, side, side. Given that triangle ABC and triangle DEC, which of the following would be sufficient information to prove the triangles are congruent? Well, we know for sure that the vertical angles are congruent, so we really need to show two sides. So AC over DC equals BC over CE would be the solution to that one. And this so we know that triangle TUQ is similar to triangle RSQ. That's because T has to be congruent to R by alternate interior angles, and the same with U and S. We know that TU over RS gives us 10 over 4, which is 5 over 2, and that's our scale factor. So 5 over 2 would be 2x plus 10 over x plus 3, because TQ and QR are corresponding. Cross multiply. So I have x equals 5. Now they asked us to find RQ and QT. Plugging 5 in to this for RQ would give us that RQ equals 5 plus 3, which is 8. Plugging 5 into the equation for QT would give us 2 times 5 plus 10, which would give us 20. In the next problem, we're given that AB is parallel to DE. Again, we know that these then would be similar triangles because of AA, knowing that angle A has to be congruent to angle E, angle B congruent to angle D. We have that triangle BAC is similar to triangle DEC. We need to find the scale factor, so we can look at AB over DE, which is 38.5 over 11. So 38.5 over 11 equals 3x plus 8 over x plus 2. Cross multiply. Solving this, we have x equals 2. And we want to find AC. AC is 3x plus 8. So 3 times 2 plus 8 is 6 plus 8, which gives us 14. And that concludes the lesson for 7-2.